This is the Master Exam Review for Standard 3. Number 1, consider the function f of x equals x to the 8th. Is this function invertible? Okay, it is not invertible for two reasons. Number 1, it does not pass the horizontal line test. And then 2, even degree functions are not invertible. Okay. Number 2, this function, f of x equals x to the 11th. Is this function invertible? Yes, it is. And there's two reasons. It passes the horizontal line test, and 2, odd degree power functions are invertible. Real quick clarification, what does a power function mean? It means it's just, this is it. There's a variable raised to an odd degree. That's it. There's nothing else on it. Okay, and the reason I had to put the power function in there is because this graph here is an odd degree function, but it is not invertible because it does not pass the horizontal line test. Okay, the only way you can say that is because it's a power function. So that's why the odd degree works. Okay. Okay, number 3. The graph is shown of that equation. We want to use the graph in any method to determine the factors of the polynomial. We're going to use synthetic division. So we're going to look at our graph, and we can see that there's 3 times where it crosses the x-axis. Here at 0, here at 1, and here at I have no idea. So we're going to use these values in our problem to solve it. So we have 2 from x to the 3rd minus 7 plus 5. You're noticing we are missing an x term. Not an x term, just a number term, sorry. Okay, so I'm going to put down plus 0. So we have 0 first. So we have, drop the first number, we get 2. 2 times 0 is 0, minus 7 is negative 7. 0 times negative 7 is 0. 5 plus 0 is 0, is 5. 0 times 5 is 0, which gives me nothing. Okay, so that's the first part of my synthetic division. Next, we saw that we had 1. Okay, that is our other point on our graph that we can find. So again, we drop the first number, which is 2, times 1 is 2, minus 7 is negative 5, times 1 is negative 5, which gives me 0. So I have 3 factors. I have 2x minus 5. Then I have the factors from above. I have x plus 0, which is just x, and x equals 1, which is going to give you x minus 1 when you make it as a factor. So these are the 3 factors of this problem. Okay, here we want to find the domain restrictions. We don't need to solve it. So we have x, 3x, and 6x. So we're looking for domain restrictions. We want to know what the denominators of our fractions cannot be. So all the x's are multiplied by number, so it doesn't make a difference which one we use. X cannot equal 0. Okay, if you put 0 in for any of the denominators, you would make the fraction that it's under undefined, which is not good. Next one, we have to factor these first. You're going to find 2 numbers that multiply to give you positive 24, but add up to give you negative 11. That would be negative 8 and negative 3. On the other side, x squared minus 64, you got to factor that too. So you have x plus 8 and x minus 8. These are the difference of 2 square problems, which we've seen before. Now I have to take all the factors we have that are in our denominators. So we have x minus 8 x minus 3 and x plus 8 all equaling 0. To find out what x cannot be, so x cannot be positive 8, negative 8, or positive 3. Okay, so we're just looking at the denominators for this particular standard. We're not looking to solve the equations. All right, and then here we have two denominators. We have x and we have x plus 3. We set them both equal to 0 and solve. So x equals 0 is already one of them. If we subtract 3 from the other side, we also have negative 3 as one of the denominators that does not work. Okay, and that is it. Okay, Rick and Linda are planning a wedding reception. Tasty Food will cater the wedding reception for a fixed charge of $200 for staff and equipment, plus $90 per person for food. I'm going to determine the total cost if the 210 people attend. So it is $90 per person for food. There are 210 people. There's a fixed charge of $200 for the staff and stuff. So we put in our handy dandy calculator, 90 times 210 plus 200 is a lot of money. 19,100. All right, what's the average cost? We take that total cost that we just found out, 19,100. We divide it by how many people came. So it cost $90.95. Okay. All right. We're given two polynomials. We want to see if they're closed under addition. So for a closed under addition, all you have to do is add up the polynomials. We have 3x squared minus 2x plus 4 plus 2x plus 5. We're just going to combine the like terms. 3x squared has no like terms next to it. Negative 2x plus 2x gives you 0, so that goes away. And 4 plus 5 gives you 9. All right? So we started with two polynomials. We ended up with a polynomial. That means this is closed. All right, use the functions as examples to show that the set of polynomials is not closed under division. So to do that, we're going to write out reduced synthetic division. We have 3 minus 2 and positive 4. For the divisor, we're going to take the 2x plus 5, solve it for 0, and get x equals negative 5 over 2. Okay, so this is going to involve a calculator. Drop the first number, you get a 3. 3 times 5 over 2 is negative 7.5 minus 2 gives you negative 9.5. All right, times negative 5 over 2 is positive 23.75. Oh. And then we subtract, or we add those two together, we get 27.75. Okay, so the answer is really ugly. Okay, so technically we're supposed to take 3 and divide it by 5 over 2. In our calculator we get 1.2. Then we get negative 9.5 divided by 5 over 2. Oh, this is going to be minus. Yeah. And then we're going to get positive 3.8, and the remainder doesn't change. Oops. So this is going to be open because there's a remainder and it's not a polynomial anymore. That's the big step out of this. All right, determine the inverse. Okay, there's two pieces to this. You don't have to determine the inverse in this. You just to show that you know what you're doing. To find the inverse, you switch around the x and the y. So this should read as x equals 9y minus 4. That's it. Next one, it should be x equals the 7th root of y plus 4 plus, oops, let's get rid of some of this, plus 9. On the next one, x equals 3 times y squared minus 5. That's it. So you need to show how you know how to do the inverse, but you don't have to show the inverse for this particular problem. And that's it. Good luck on